We're going to take a look at number 4. It is crazy to think that a nuclear reactor uses as much water as 5 million people use, and they use that in about an hour. So that's kind of a tall order for us living in a desert. They must do something with that water. But anyways, let's look, when that nuclear reaction takes place, how much energy and how hot will the water get? So it says we use, the mass of all that water, the 30 million gallons, is 1.14 times 10 to the 11th. So mass equals 1.14 times 10 to the 11th, right, grams. It absorbs 3.816 times 10 to the 13th. So think about that. 3.816, so 1, 2, 3, 7, 8, 9, 10, 11, 12, 13. This is how much energy it's absorbing from this nuclear reaction, right? They need so much water to keep this reaction taking place, and that's why nuclear fuel works, because it has so much energy stored in it that we can get and use. Well, we don't really want to write the number that way. So 3.816 times 10 to the 13th says, what will be the temperature of the water if the initial temperature is 20? So we know the initial temperature is 20 degrees, and we're looking for what is the temperature going to raise up to after it absorbs all this energy. Now, if it's absorbing energy, we know that that's endothermic. Energy is going into our system, and our system is really just the water. That's what we're concerned about. Okay, and remember, the heat capacity of water is 4.184. So we write our equation, right? Our Q, or our units of joules, Q is the variable. So 3.816 times 10 to the 13th equals our mass, 1.14 times 10 to the 11th, times our heat capacity, times our final temperature minus our initial temperature. Okay, sometimes the algebra kind of gets in the way. So let's see something real quick. See if I can find a calculator. Okay, so here's our math, right? So when you type in your scientific notation, right, you have to be careful how you do it, because if you're not kind of linking it together, you really need to put everything in parentheses, right? So I would be 3.816 times 10, and then I would have to get to the power of, where is that at on this calculator? Maybe here, there we go. To the 13th and the parentheses, right? And now I'm going to divide, but I have to make sure that I put that 1.14 in parentheses, right? If I just do 1.14 times, what your calculator will do is it will put the times over here to the right of the fraction. It won't link it all together. So you really need to make sure that when using your calculator, you put the parentheses on it, or it won't work like it was just showing you. So 1.14 times 10, where is it again? To the 11th, right? Enter. So now I've moved this over to the other side, right? Because I divided this side by 1.14 times 10 to the 11th. So I got that answer. Now I need to divide by 4.184 again. So divided by, my answer divided by 4.184. So now I know that 80 equals TF minus 20. So I'm going to add 20 to both sides, and I get my TF equals 100 degrees Celsius. Right, so what I was saying is with this 1.14, if you punch in your calculator and you don't hit and put it in parentheses, what it'll do is it will divide by 1.14, and then it will multiply that by 10 to the 11th, and that's not what you want, obviously.